So in this video, I'm going to show you how to create a model using the Vision AI service within OCI to detect whether a person has a brain tumour or not. So the first thing that we need to do is if we go into Analytics and AI and go into Vision, we then select the Custom Models section from within here and select to create project. I'm going to give this the name brain tumour. Create the project, which will just take a few moments. Right, now the brain tumour project has been created, as you can see by active. What we'll do is we'll go into it. And the first thing that we need to do is to create a model that we'll use for the project. So we'll select create model. We'll select the type of model. Now what we're wanting to do here is to classify an image, essentially to see whether that image depicts somebody with a brain tumour or not. The other option is object detection, where you can use to identify specific objects within an image. So for example, a picture frame or a mug. So in this specific case, we will select image classification. Now we don't have a data set for that, so we will create one. So by selecting that option, it takes us through to the data labeling service. So what we need to do here is to create a data set. So what I'll do is I'll call the data set brain tumour dataset. We then select the format. So here we're going to be analysing images and also the annotation class. As we're doing classification, I'm just going to go for single label. Essentially that means each image that we analyse will have a single label, which would be either yes, that image depicts a brain tumour, or no, there isn't a brain tumour present. There are cases where you'd potentially need to use multiple labels. Next, we need to add files to the dataset. Now these are the files that we will use for the training of the model. Now what I'll do here is select from object storage. And if I go to select a bucket, you'll see that I don't actually have any buckets within the compartment that I'm provisioning this dataset within. So what we'll do is we'll go to the console, go to storage, go to buckets, and then within the AI Vision compartment, we'll select create bucket. We'll call this brain tumour bucket, and then hit create. Now if we click into the bucket, what we'll do is we can upload the files that we will use for training. Now what I have is a publicly accessible dataset of images that contain a mixture of those that have brains with brain tumours and those that have them without. So what I'll do here is I will copy along those images. So you may notice the names of these. Now to aid me in doing the data labeling, what I've actually done is each one of the images that doesn't have a brain tumour starts with the word no, followed by the file name. So what I will do is I'll drag them across and get them uploaded to object storage. So we've uploaded 30 images that do not have a brain tumour, and they're now sat within the object storage bucket. What I also need is another set of images, but for those that do have a brain tumour. So what I'll do is I'll select 30, I'll just go for the first 30 images that do have a brain tumour, and I'll copy them across to object storage, hit upload, and then I'll hit close. And now what we can see is within the bucket we've got 60 objects, 30 of them are images of a brain tumour and 30 of them are images of not. So what we then need to do is go back to the data labeling service. I'll just quickly hit change the compartment and then flip back, which will refresh the view. And I should now be able to select the bucket. So I'll select the brain tumour bucket, and what we'll then see is the files that have been uploaded to that bucket. So the combination of images with and without brain tumours. I then need to select the labels that will be added to these images. So as I touched upon earlier, I'll simply have yes, which will indicate that an image depicts a brain tumour, and no, which depicts that an image doesn't. We'll then hit next, and we'll then hit create. Now what it now does is generates records for this specific data set. Once this has been completed, we then need to go through the process of, for each image, assigning a label to it. That would be to say, hey, this image has a brain tumour, or no, this image doesn't have a brain tumour. Now what I'm going to do is I'm going to do this manually for some images. However, with it being such a large amount of images, it's probably not a great use of my time. So I will run a script that will automate the data labelling. And the way that that works is it will look at the name of the file. And as you saw earlier when I uploaded the file names started either with no or yes, and my basic script will automatically add a label based on the beginning of the file name. So for example, if it sees a file called yes3.jpg, it will tag that with yes. If it sees an image with no, as in no 64.jpg, what it will do is it will tag that as no. It just makes things a little bit quicker and easier and saves me having to manually go through the dataset to do that. Right, the record generation is now successful, and what we can see, it lists all of the images that we've uploaded. And next to each one of the images it says the status of unlabeled. So what we need to do before we train the model is add a label to each. So what I'll do here is I'll just show you how you do that using the UI. Now I'm not a brain surgeon, so the only reason why I know that I can tag this with a yes is the fact that the dataset I was provided made it pretty clear which image contained a brain tumour and which didn't, which I also integrated by updating the name. So for this specific one, we'll say yes, and then we can go save and next and carry on through it. Now, what I will do now is I'll cancel. We see we've got some that are labelled, and I'll go to one of the images later on in the data set that doesn't have a brain tumour, just to show you the difference. So if we go to this image here, I can then label that as an O and save and next. I'm just going to cancel out of this. What I'm going to do is go away, run my magical script that will automate the data labelling. I will share the link to that as it saves a bunch of time when you're doing any activities like this. And then I'll come back once that script has run successfully and we can carry on training the model. Okay, I've run the script. I'll just refresh this screen, and what we should hopefully see now is all of the individual images have been labelled automatically by my script. As I mentioned, I will share a link to this so you can run the script yourself if you want to avoid having to manually label each individual file, which is obviously very painful. So if we now go back to the project, so if I go to Analytics and AI, Vision, and go to my brain tumour project, and I go to create a model, I can now choose the data set that I have created. And as we can see, as I only have a single data set within this compartment, it's picked up that brain tumour data set. Remember, I'm selecting image classification, and I'm going to call this brain tumour model as a name. I'll go for the recommended mode. It says it may take up to 24 hours. However, with such a small number of images as this, probably take a lot less time than that. Hit next, and then select create and train. That will go off in the background and create the model. And once the model has been created, we can then throw some test images at it to test the model to see how successful that is. So I'll come back once the model training has completed. Okay, now the training is complete, the model is ready to test and use. One of the really cool things about AI within OCI is that you don't need in-depth development skills to be able to test things like models. It's actually possible to do it using the OCI console. So what I'll shortly demonstrate is how we can use the console to analyse some images against this model to detect whether a brain tumour is present or not. One thing to point out for those of you maybe a little bit eagle-eyed is that the precision of this model is really low. It's only 33%, which is obviously not ideal, means the results will not be fantastic. The reason for that is likely that I only provided it with a very small number of images to train. In a real world scenario, you'd likely use hundreds or thousands of images to actually train your model. As this is a quick, dirty demonstration, I only opted to use, I think, 50 to 60 images, which explains why the precision is so low. In any case, in order to test the model, I can simply point this to object storage to browse files, or I can upload a local file. So what I'm going to do is I'm going to provide it with a file from a separate test dataset that I have, which can be used to test the model. So I'm going to upload a file now to it, and that will analyse it and then provide the results. So there's the image that I've uploaded. On the right hand side we can see the results. So we can see the results that it provided was a 50% confidence of no with a 49% confidence of yes. Now this image is actually no, so it was accurate. However, the confidence levels are not great. It's obviously very borderline. The other nice thing is it'll actually show you the raw request and the JSON response, which is, if you are using development, is quite nice because it gives you a good view of the data that will come back from the API. Now what I'll do next is I will provide it with a second image of a brain that does have a brain tumour, just to see how well it does on the analysis of this. So let me drag that across. Analyse very quickly, and you can see this one's a little bit more confident with a confidence level of 62% of yes and 37% of no. Again, this was accurate because this image did actually have a brain tumour. So you've seen the demonstration today. Hopefully it's got you excited about using the OCI Vision AI service. I've shown you that creating custom models are not really that complex at all. And the real good thing about this, there's a really good rich API. So in order to use the model, you can quite rapidly build web applications and other applications that integrate with the model to test and validate any images that you want to throw at it. So thanks a lot for your time today. Really appreciate it.